Good morning and or evening and or afternoon, ladies and gentlemen. It is time to talk about permutations. Yep, that's permutations. So when we're talking about a permutation, it's got two different elements. First of all, we have to select from a group, and then we are going to order them in a subgroup. So we need both of these elements in order for it to be a permutation problem. So let's take a look at an example. So, how many ways can 7 friends sit at 4 seats? So the first part is that we are selecting 4, and order matters. So this is indeed a permutation. So pause your video and try to figure out on your own how many ways we can fit this requirement. Assuming you've paused your video, the first way to think about this is to realize we've got 4 seats. There are 7 different ways a friend can sit at the first seat, and then 6 ways at the second, 5 ways at the third, and then 4 for the 4th seat. So another way to write this is 7 factorial over 7 minus 4 factorial, which gives us this crazy computation. Alright, I want to talk through this a little bit more. So what's happening up top is sort of the way to think about it logically. Well, wrong pen, wrong pen. And this would be the formula way on the bottom. The formula way is really nice because sometimes these problems are illogical or very difficult to grasp conceptually. But if you can understand and visualize what's happening, it's pretty easy, at least in the top for the logical. So first seat, 7 students, then there's only, or 7 friends. Then there's only 6 friends left to choose from the next seat. Then 5 are left, then 4 are left, and then there's no more seats. Multiply them all together, you get 840. The other way to do this, take 7 factorial over 7 minus 4 factorial, which is 7 factorial over 3 factorial, and I want you to see the connection between these two. In that hold on, getting another better color. I can do this. Come on. Never mind. That 6 times 5 times 4 is right there. Isn't that beautiful? So 7 factorial just means 7 times 6 times 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. And then we cancel out the 3's and the 2's and the 1's, giving us the 840. So this leads us to the general rule of permutations. Let's say we have n things, n objects. We want to order them into k different ways. What we are going to notate this as is n permute k, or npk. And that is n factorial over n minus k factorial. So let's take a problem. Got 10 teams. And we're going to choose a top 4. How many different ways is there to choose a top 4? Pause your video. Okay, assuming you've paused your video, let's take a look. This would be 10 permute 4, which is 10 factorial over 6 factorial, which is 5,040. One thing to keep a note of is that 6 factorial, I skipped a step here, that's 10 minus 4 factorial. So the 10 minus 4 gives us 6. 6 factorial, that gives us 10 times 9 times 8 times 7. So there are 10 ways to choose the first team, 9 ways to choose the second, 8 ways to choose the third, and 7 ways to choose the fourth. So I bet you're interested in how to use your calculator here. If we want to do 10 permute 4, these are the steps. So why don't you try it in your calculator and make sure you can get the correct answer. Pause your video. So I'm assuming if you're not able to figure out how to get this up on your calculator, you're going to ask me or ask another student. Let's move forward. Another example problem. Got 1,000 students running for student body office. How many ways can you select a president and a vice president? Now that I'm looking at this, that looks extremely confusing. Let's change that to there we go. A little less confusing. So in this case, we're not necessarily ordering them, but maybe we are. President is one choice, vice president is another choice. It is very important that we keep those two options distinct. So here's how we do this problem. 1,000 permute 2. That gives us 999,000 possible ways to choose a president and a vice president out of 1,000 students. Alright, take a look at this problem for practice. Let's say you have 15 baseball players and we need a lineup of 9 players. Now in a lineup it's very important what the order is, so picking 9 players is not just enough. We need to order those 9 players. So pause your video and try to answer this question. Assuming you've paused your video, the answer here is 15 permute 9, which if you're doing this by hand would be 15 factorial over, let's see, 15 minus 9, that's 6 factorial. That should give us, yep, that's right, 1,816,214,400 possible baseball lineups. Well, and I can't spell, whatever. As long as I know I can't spell, then I can make corrections. Now, especially when you're thinking about permutations, a lot of students get freaked out because they get these giant numbers. You have to remember that there's a lot of different ways to create a lineup of 9 players. There's 15 different guys for the first spot, and then 14 different guys for the second spot. You're already at 15 times 14 for just the first 2 players. Every single selection makes this even more and more complicated, and these numbers can get out of control pretty easily. Now I know what you're thinking. But Mr. Wiedenhoft, what if we care not about order? What if we just want to choose 4 people and don't really care who's first, second, third, or fourth? Well, ladies and gentlemen, that's coming up next with combinations. So, see you next time. Have a great stats day.